been an incredible conference. DevOps talks, conferences are always a lot of fun. This conference brings practitioners together, and we get to talk about DevOps. What is DevOps? How does DevOps evolve? How does it change into the coming years? So it's incredible to see all these practitioners, these people being here with us today. I think the key purpose of this conference is for us as a community to discuss how DevOps will actually evolve into the future, right? Because we're bringing pioneers from various companies and they share their experience. And together as a community, as a group, we can work out where is DevOps moving to? What does it look like next year or in 5 years or maybe even in 10 years, if that's possible. But this is a necessary conference to help us think about what it is now and how it will change in the future. Oh, I will absolutely come again. Yeah, if I'm invited as a speaker, I will come back, and I will always come back as an attendee.
Can we switch to HTML? All right. Can everyone hear me? No? Lapel's not on? It's on now? OK. So good afternoon, everybody. My name's Graham Polley. Nathan just introduced me, so I'll probably skip that. I work at Servian. Servian, our consultancy, is about 260 of us. And I primarily work in the data and analytics space at Servian, and primarily around Google Cloud Platform. So we tend to use Google Cloud Platform for a lot of the data and analytics and serverless tools. So I'm going to talk to you a little bit today about what data and analytics looks like on GCP using some of the tools on the stack. But also, as echoing John's comments from earlier on, you still need DevOps processes around serverless, right? You can't just deploy things willy-nilly and expect them to work, even though you're not spinning up any VMs yourself or servers. So I'm an engineer. I don't really do slides. Well, I don't do them well. So Nathan asked for a show of hands earlier. I saw a lot of engineers in the audience. So is everyone cool with seeing a live demo and actually looking at some code? And pray, yeah? OK. So hopefully the demo gods are on my side today. For those of you who may have given presentations in the past, live demos are inherently risky and scary. So a couple of disclaimers before we get started. I have 2 slides, by the way. This is one of them. Actually, that's a lie. There's 3. So I am Irish. You might have picked it up from my accent. I can't pronounce TH, so when you hear me say silly things like tree or 33 and a third or true, please try not to laugh too loudly, or I'll spot you and I'll ask you to leave. The second one is I'm a software engineer. GCP Practice Lead is just a fancy name they give me because I know a little bit about GCP, Google Cloud Platform. I've been working on it for about 5 years. So I'm a software engineer. I'm not a data scientist. I'm not smart enough to be a data scientist. I can't build machine learning models. But what I do is I build those big scalable pipes for enterprises using Google Cloud, because we see it as a differentiator. And hopefully you'll get a feel for some of those tools on the stack today and how DevOps plays into that. All right, so let's get started. What are we going to look at today? So a common pattern we see on our projects that we've developed is batch ingestion into GCP, and then performing massive scale data and analytics on top of that. So let's have a look at what that looks like on Google Cloud Platform. So you've got some files. You first upload them to GCS. GCS is Google's equivalent of S3. I assume most of you, just actually, who's actually worked on Google Cloud here? All right, there's a few. And data and analytics? 3, 4 hands. OK. Well, hopefully you'll get a bit out of this. So GCS is Google's S3, right? Simple. I'm not going to go into that. Blob storage, very, very simple. Cloud Functions is Google's equivalent of AWS Lambdas. It currently supports 2 languages, Node and Python. The demo I'm going to show today is using Node, because my Python code sucks. Dataflow is Google's managed ETL service. Who's heard of Apache Beam? Nobody. OK, so Apache Beam is the next, well, Google are calling it the next generation for massively parallel processing. They developed it internally. It was known as Millwheel and Flume, and they've now open sourced that as Apache Beam. Dataflow is Google running Apache Beam pipelines for you on Google Cloud Platform. You don't spin up a single server. You don't spin up a single VM. Google manage all the infrastructure for you. So you can get the theme I'm going with here. No spinning up of servers, no spinning up of VMs. Yeah? Focus on the problem. Don't focus on the infrastructure. Of course, there's VMs under the hood. Well, actually, there's containers under the hood. Google don't run VMs. They actually run containers for every single tool on the stack, including VMs. So a VM on GCP is actually a container, by the way. But that's a whole different story. And then the end game is to get it into Google BigQuery. Anyone heard of Google BigQuery? Great, actually a few people. It's the gateway drug for GCP, in my opinion. It's the best tool on the stack. There is no tool like it. You can kind of compare it to AWS Athena with Kinesis plugged on or bolted onto the side, because BigQuery has a streaming API as well. A little bit of Redshift, but Redshift doesn't have that separation of storage and compute like BigQuery does. So BigQuery will just scale its compute and scale its storage for you. And again, you don't specify any servers or any infrastructure for that. So that's all well and good. So we build pipelines like that a lot for our customers and on the projects I've worked on. But how do we automate that, and how do we test it and deploy it? Because we're building petabyte scale pipelines, okay? So Google have this cool tool called Cloud Build. Cloud Build used to be called Container Builder, and they recently rebranded it at their annual conference last week. Cloud Build, essentially, who's used Travis and Circle CI and all those tools? So this is Google's managed version of CI/CD. It will spin up an instance for you when you invoke a build command on it. It will look at your YAML file, which we'll have a look at, and it will run a step in each of your pipeline steps in a container. So disposable environments, spins up a container, runs anything you want, produces some artifacts, and you move on. So Cloud Build encapsulates the whole pipeline, and we'll have a look at that. So Cloud Build can be hooked up to cloud source repositories. That's Google's managed Git repositories. It can also mirror, I don't even know if that's a word, mirror, that's the Irish accent, by the way. It can mirror your GitHub repos and also your GitLab repos. So for this demo, I'm going to be mirroring one of my GitHub repos. And we have a trigger set up on that, so when I make a commit, it will automatically kick everything off, and we'll see the whole thing break, probably, because it's a live demo. Stackdriver. So Stackdriver is what Google give you out of the box, all your logging. So Mike was talking earlier about logging on Kubernetes is shit hard. Actually, Kubernetes is shit hard. So Stackdriver gives you all your logs for free. Well, not free, there's a slight charge on them, obviously. So you can do all your logging, analysis, debugging, alerting, monitoring. But the point here again, if you look at this diagram that we're going to demo today, I've got a screen down here. I don't have to keep turning around. You don't have to spin up a single server. Yes, servers are happening, or Google are spinning stuff up under the hood for you, but this is completely serverless. Yay, buzzword. Okay. So let's just, is everyone happy to just jump to a demo? And yeah? Okay, cool. So let's have a look. All right, so you define a Cloud Build configuration file using sweet YAML. Everybody loves a bit of YAML. Step one of my pipeline is to pull my source code from Git. And what I'm specifying here is Google give you pre-built images out of the box, i.e. containers. So they store them in GCR, which is Google Container Registry. In your YAML, you simply say, I want a Git container, I want a Java container, I want a Go container, and it just gives you one like that. You're running everything on Google Pipes, so it's incredibly quick. Yeah. So the first one is pull my source code repo. Google, Cloud Build spins up an instance for you under the hood, running all these containers. It's obviously running something like Docker. And mounts the workspace, so you now have all your source code running on that machine. It's ephemeral. What was the word that was used earlier? I can never pronounce it. Ephemeral, yeah. Jeez. I was practicing it all lunch, and it's the bright lights that got me. So obviously the container runs, and then it's gone afterwards. Yeah, so disposable environments for the win, in my opinion. Spin something up, do what you need to do, and then tear it down. But let Google do all that for you, yeah? The next one's actually quite interesting. Anyone notice the difference? I'm pulling a Terraform image, but I'm not actually pulling it from GCR because Google don't actually offer a Terraform pre-built image out of the box yet. Just last week they did do one, but I'd already built my demo. This is pulling from Docker Hub. So it's a public image, yeah, and they'll actually scan it for vulnerabilities as well as it comes down, which is really nice. So I'm using Terraform. It's probably a bit of overkill for this demo, but I wanted to show you that you can use Terraform to, say, in our case, I need to create a bucket on GCS, right? So I need that bucket in order to drop all my binaries in and so on. So I do some Terraform steps. I'm using Java, don't judge me. The reason why I use Java is because that's my background. I was a Java engineer. But the Java SDK for Dataflow is actually a lot more mature than the Python one. So if you are looking at using Dataflow, I would recommend using Java at the current point in time because the Python one still is lacking a few features, okay? So this is saying, hey, give me a Gradle container. I want to run some Gradle processes. I want to build my application. I want to build some not tars, but I want to build some jar files, and I want all those dependencies to come down from Maven, and then I actually want to run it. So that's running my Dataflow pipeline, and the Dataflow service will actually scan the class path dependencies, upload all my binaries onto GCS, spin up a cluster, and then take my code and put it on every single worker in the cluster and run it in parallel. Does that kind of make sense? It will also auto-scale depending on the throughput. So the more data that it sees, the more VMs it brings into the stack, or the more containers, actually, it's not VMs. And as the throughput dies off, it will start scaling down. I'm also running some unit tests on my Cloud Function. And then the final piece of the puzzle is I'm going to deploy my Cloud Function, which is just listening to that bucket. When it gets triggered, it kicks off the Dataflow pipeline to start ingesting that file in parallel. And I do that using the gcloud command. So you can see it. This is the staging bucket. This is the trigger bucket, and so on. And then just for the sake of brevity, I'll get it to copy a file into that bucket so we can see the pipeline actually running. OK, so is everyone with me so far? YAML, it's not terribly complex. We're kicking off. We're going to deploy a petabyte scale pipeline on GCP using Cloud Build. File arrives in GCS, triggers a Cloud Function. Cloud Function triggers a Dataflow template, which spins up a worker pool, puts all my code in parallel on each of the workers in the stack, reads the file in parallel, and then writes it to BigQuery, where analysts can work their magic. And then there's one final step in it, which is copying any artifacts up to GCS to do craziness later. So out at the Google Cloud standard side, you could hook this up to, say, Spinnaker, and then do your Canary releases or your Canary deployments on Kubernetes off the back of that. I just kept it simple. But the guys are running a demo out there with Cloud Build and Spinnaker. OK, so let's have a little look at something else. So this is the Cloud Function that's going to run. It's not overly complex. What is that? 50 lines of code. It's just listening to a bucket and triggering. The crux of it is, so I've written this in Node. Cloud Functions does support Python now. But as I said earlier, I suck at Python. So I also suck at JavaScript. But anyway. So this is the crux of it, actually. This is the Cloud Function triggering the Dataflow pipeline and passing the name of the file that's arrived in the bucket as a parameter to that pipeline. So it's dynamic, right? So whenever a new file arrives, it takes the file name, gets triggered, passes it to the pipeline. The pipeline goes, hey, new file, let's start ingesting it. OK, so that's that. This is my Terraform script for creating a bucket initially. So I do need a bucket to host all this stuff. Very, very simple. You can get much more complex Terraform scripts. This is very, very simple. But you get the point, right? I can pull a Terraform container. I can point it at this, say run it, and it creates a bucket for me. Java. OK, so this is my Dataflow pipeline. Very, very simple, right? And you'll notice that I'm not specifying how many workers to spin up or how to upload my code onto each of those workers in the stack. The Dataflow service handles all that for me. So what I'm saying here is get the input file that's arrived, read it, do a parallel operation on that file, so do some transformations on the cluster, and then write it to BigQuery to a data set called DOTC18. By the way, The official hashtag is DOTC, so you can copy it from that. It's specifying the schema of the table that we're writing to in BigQuery. And this is the process transformation. So I'm just splitting. So the data set that I have is a publicly available data set on Google Cloud. It's all Wikipedia page views since 2012, I think it is. So big data sets. So you can imagine what this is: year, month, day, the name of the title, the number of page views. Really, really simple. Just splitting it, horrible regex, but you get the point. All right, so if we jump over to Cloud Build, so Google Cloud Platform, I'm now in Cloud Build. Someone's broken the build. That might have been me deliberately breaking the build for the purpose of this demo. But if we click in, these are all my builds that I've run. If I click into one of the builds, so Wi-Fi is keeping up with me so far. That's really good. You can actually also click on the SHA commit of that, the commit that, or the push that went up. Oh, and someone broke it, right? That looks like me. So the build is breaking, and the unit tests are failing in Java. So we need to get that fixed. Okay. So I actually have a fix ready to go, believe it or not. So if I do a git diff, all right. So someone who shall remain nameless, checked in the wrong header file for the schema for the BigQuery table. Can anyone spot where the error is? It's pretty easy, right? It's missing a column called year, which was the year of the Wikipedia tree. So this is my fix ready to go in. Let's commit that. Oops. Oh, my typing is awesome. I should be fired for this. All right, committed. All right, let's push it to the repo. So I have a trigger set up, yeah? So when I push to that repository, then hopefully, if the demo gods have been with me, we'll see a cloud build kick off and deploy that entire pipeline and actually then trigger a system test of it. Now, so I am pushing directly to master. You probably don't want to be doing that in your environments. It's just, again, for the purpose of a demo, you probably want to be pushing to dev or UAT or whatever it is. And using proper pull requests and merge requests, I'm just pushing directly to keep it simple. So if we jump back here, we go up here, let's have a look. All right, so it's working. Cloud Build has detected a change in the repository. It's now going to execute that YAML script, and it's going to create a container for every single step, and it's going to make sure everything builds and deploys. Is that making sense so far, or have I lost a lot of people? I think everyone's kind of still with it. All right, great. So let's jump in and have a look at the build running. So what's really nice about this as well, can everyone read that, or is it too small? It's too small. So, is that a bit better? Okay. So you get all your logs. This is Stackdriver now, taking all the logs from all the services on GCP that we're using. Cloud Build, Dataflow. You can scroll down. You can download your logs if you really want to download your logs. A nice trick that I like to do is you can actually export all your logs back to BigQuery and do all your analysis on your Stackdriver logs directly in BigQuery using sweet old SQL, which is my favorite language. So you have a look at this, right? So it's pulling from Docker Hub, it's pulling a HashiCorp Terraform image, it's initializing Terraform. Oh, yes, it successfully, oh, okay, and it created a bucket. Cool, so that's the first step done. Then it drops into Gradle, and it should be no surprises here that building a Java application using Gradle as my build tool seems to take the longest. So if we have a look at why that is, it's pulling all the dependencies that Apache Beam needs to run that pipeline, or even what my code needs. I could be pulling third-party jar files from all over the place. But I think the point here is none of this is running locally on my machine, right? This is all running on Google Pipes, so they've got pretty decent bandwidth. I would hope they have decent bandwidth. So let's have a look at that. That's doing lovely log files. Now I'm running some tests to make sure everything runs. So all my unit tests for my cloud function. And then I'm going to deploy the function. And we've gone green, which is successful. OK. So we now have fixed the build. I have fixed my previous bug. You can see the trigger was push to master branch, which was me. Let's have a look at that one more time. So if I hit the SHA commit of that, zoom in, Okay, there's my bug fix. I've fixed the schema. So the last step, if you remember, if we go back here to Cloud Build, it copied a file into the bucket. So copying that file into the bucket hopefully will have triggered the Cloud function, which hopefully will have triggered the Dataflow template, which hopefully will write to BigQuery. And then we can do some analytics in BigQuery. So let's have a first look at Cloud Functions. Did it actually deploy the Cloud function? Looks like it did. So let's have a look. That might be from earlier, so let me refresh. Has anyone got the time? Does that sound about right? 2:37? Beautiful. All right, so we've got a Cloud function. If you click in there, we can even have a look at the code. We can debug it. We can test it directly from the console. I probably don't recommend clicking around in the console. We tend to do all our prod deployments using service accounts. Nobody is allowed near the console for deployments. But you can actually go in here. You can have a look at what's triggering. It's triggering on this bucket here, which is where we're going to upload the file to. You can even have a look at the source code. There was the source code that we looked at in my development environment, right? So you can see how this is working, right? It takes my Cloud function, uploads it to Google Cloud Platform. Whenever it's invoked, it spins up a node environment for me in a container and runs it. Close that. So we've got a Cloud function. We've got a bucket. Let's have a look at Dataflow. All right, so it's actually kicked off a Dataflow pipeline now. So again, 2:38 p.m., click in here. All right, so what's actually happening here is it's spinning up a cluster for me. It's processing 261,000 elements a second. That's actually not a lot. I've seen this hit about 6 million elements a second on some of our big fat pipes on the projects that I work on. But you get the idea, right? It's just spun up 5 instances. It's reading. You can see this number ticking up. These are the number of elements that's been read in parallel across that cluster. The file that I threw at it has about 25 million. So it's not huge, right? It's pretty small, but you get the idea. What's actually really, while we wait for that to finish, so it's going to read the file, it's going to transform it, i.e. do some ugly regex that you saw in my Java code, and write it to BigQuery. Let's have a look at BigQuery. Has anyone seen BigQuery like really scale? Nobody? Awesome. This is going to be great. Okay. So this is BigQuery. It's SaaS, right? Everything you see both in the console and in tools like BigQuery is just backed by a REST API. Yeah, so you don't have to use the console for this stuff. It's got a full REST API. It's mature. BigQuery is what Google call internally as Dremel. They've been using it for about 10 years for their own analytics, and BigQuery is what we see externally. You throw some SQL at it, you throw some data at it, you're done. You don't even define indexes. You don't have to vacuum. You don't have to patch. Google do all the heavy lifting for you. So I've got a sample data set here with some SQL. Not overly complex SQL. I'm doing some aggregations here. I'm doing a sum on this table. It's, again, the same data set that we're looking at, Wikipedia. It's got 1.25 million records. I'm putting a predicate filter in, so I'm going to search for Sydney, because we are in Sydney. I just fixed this before it came up on stage. It was Melbourne before that. I'm based in Melbourne. It's doing some aggregation here. But here's the kicker, right? BigQuery runs in parallel. So it runs on a system called Borg. Borg is what Google use internally for their container management. When you use Kubernetes, that's actually where it comes from. It comes from Borg. Google open sourced it as Kubernetes, but they still run Borg. They ship about 2 billion containers a day on Borg across all their products. So Kubernetes is definitely a good bet. You're backing the right horse. If Google did it with 2 billion containers, it's a good tool. But my talk, I'm not smart enough to understand Kubernetes. Kubernetes is hard. So respect, Mike, for getting your head around Kubernetes. So let's have a look at hitting 1 million rows, right? So BigQuery does a full table scan on every single query. There is no such thing as an index in BigQuery. It does a full table scan, no matter how big the table. So we did 1 million rows in 3.7 seconds. Can everyone read that? Or is it a bit small? Down here, 3.7 seconds. That's no fun. Let's do 100 million rows. Everyone see the timer? At 2.9 seconds, it aggregated and scanned 100 million rows, which equated to 5.17 gig. That's really not that big. Let's go 1 billion. I'm just killing some time while the Dataflow pipeline finishes. All right, so 7 seconds for a billion row table scan in BigQuery. Oh, let's go a little bit bigger. Let's go 10 billion rows. And I'm not telling you porcupines here. So let's click to the table. Let's have a look at how many commas are in there. Yeah, that's a lot of commas, right? 10.7 billion records. It's half a terabyte. Let's scan it, aggregate it, order it. And when you order in BigQuery, it forces BigQuery to shuffle all the data across the network onto one node to do the final order by. But this is running on a petabit network called Jupyter that Google use for their own internal infrastructure. It can shuffle a terabyte a second across the network. So 12 seconds for half a terabyte. That is the power of BigQuery, and that's why it's my favorite tool on the stack. Because I just give it data, I just write some SQL, I'm done. I don't care about any of the infrastructure underneath. And that scares some people, right? And I get that. But once you start actually playing with this tool and actually using it in production, you immediately see the benefits of it. It's not perfect. I don't work for Google, so I don't have to say it's perfect. It's got a few little things that they need to fix. One thing is if you compare it to AWS Athena charges you on the compressed data. BigQuery charges you on the uncompressed data, and that kind of sucks, right? They need to fix that stuff. But for me, if you take away anything from this presentation, it's that I can't pronounce TH, and I can't pronounce that word that I did try and pronounce earlier on. Ephemeral? No? Oh, shit. It's this, BigQuery. It's the best tool on the stack on GCP. But we can go a little bit bigger. Let's do 4 terabytes of data. OK, let's run that. So not telling porcupines, let's go in, have a look at the table. Does anyone want to take a guess at how long 4 terabytes takes to aggregate and shuffle on this? John, did you? 25. You've seen this demo before, right? Oh, right. OK. So BigQuery is not linear. So it's not deterministic. You will never get the same query times in BigQuery. And that's because it's actually a multi-tenanted system. So it's actually Borg, which is Kubernetes. It's Borg running under the hood, spinning up thousands of containers to process your query. And it depends on the load on the cluster at that time. But my God, is it fast. We just processed 4 terabytes in 30 seconds. That is the power of BigQuery. All right, so fingers crossed. Go back to my pipeline. Oh, no, it's finished. Yay. OK. So let's refresh that. How am I doing on time, Igor? Am I OK on time? OK. What time did I start? Yeah, OK. OK, so it's read 24 million records. It's transformed them. It's written them to BigQuery. So let's prove that. Let's jump back to my favorite tool, BigQuery. So we should now have some data that we read in. Refresh that. All right, so DOTC18 has a wiki demo table which got created on August 27th at 2:43 p.m. Let's query that table. Make sure there's data in there. And there we go. That's a full pipeline running on GCP without spinning up a single VM. So pretty cool if you ask me. All right, so let's jump back to Cloud Build. Cloud Build looks good. So one thing I mentioned earlier, right? You can actually export all your logs back to BigQuery. So you can actually export anything you want on GCP back to BigQuery. It's not just Cloud Build logs, it's anything. So if you go to Stackdriver, which is Google's logging tool, have a look here. And I'm filtering for all my Cloud Build builds, and you can even filter by the build ID and so on. You get the idea. Everything's there. You don't miss any logs. Well, the SLA is 99.99%, so maybe. But look, we put our trust in Google. They've got some of the best engineers in the world. Let them do all the toiling with infrastructure. We don't care about it. We just want to build solutions, and we want to solve the problem. And that's why I work a lot also on AWS. But a common pattern I'm seeing is a lot of enterprises actually shifting their data off AWS. So leaving their infrastructure on AWS, so EC2, autoscale groups, CloudFormation, whatever, leaving that on EC2, but actually all their data offloading it onto GCP for analytics because of tools like BigQuery and Dataflow. And people are probably going, but what about egress costs and ingress costs and all that stuff? It's negligible. When you're able to scale like this, the speed at which you can iterate on your solutions far outweighs any egress costs out of Amazon. And there's also a few tricks that you can do. You can compress your data. Is there any AWS people in here? Great, okay. I hacked one of the libraries to compress all the data going out of Amazon to reduce our egress costs. So I wrote a blog post on it. You can find it. Just don't give it to any AWS people. They don't like me for that. Okay, so that's the demo. Demo gods were on my side. Awesome. So I did promise you code. I did promise you actually spinning stuff up. The point being, did you see me spin up a single server? No, right? It's all PaaS, it's all SaaS. But you still need DevOps tools around it, like Cloud Build. It doesn't have to be Cloud Build. I was just showing you Cloud Build as a cloud-native tool on GCP. It could be Jenkins, it could be Travis CI, it could be Circle CI, any of those tools. But the point I'm trying to make is you still need DevOps around any of your service applications. And Peter, who spoke earlier from a Cloud Guru, he said the exact same thing. He comes from a very serverless background, and he also, I think we agree that you still need DevOps around it. Okay, so what are my key takeaways? Apart from BigQuery is the best tool on the stack. Oh my God, I've said that like 100 times. Let's skip that. So Cloud Build, a lot of people think it's just for building containers. It's actually not. Yes, you can build containers using Cloud Build and push them to GCR, which is really, really cool. But it does so much more, right? It's just a container. You can do anything in a container. And I don't know if people heard about it, but Google released serverless containers about 4 weeks ago. That's like the next generation of serverless. It's basically you give them a Docker file, they run it, you don't care about any of the infrastructure. So it's more abstracting even Kubernetes further away from you. So you've got, is everyone familiar with GKE, which is Google's managed Kubernetes? They're abstracting that even further away from you. So you just give them a Docker file, they spin up the container for you and they run it. So it's not just about containers though. You can build, you saw it, jar files, WAR files, whatever you want. Let the cloud do the heavy lifting for you. I think I've reiterated that point quite a few times. I don't care about the infrastructure shit anymore. I just want to solve the problem. And Google do a really good job of that, right? They abstract a lot of the details away from you. You saw that with BigQuery and Dataflow and so on. That said, some of the tools, in my opinion, on GCP are still maturing, like the web UI for Cloud Build. You can tell it was written by or developed by engineers. It's not that pretty. You can't do complex workflows with Cloud Build yet, so you can't have